Greetings everyone at the ISDA conference. We are going to present our paper ID 412, an Ensemble Multinomial Naive Bayes classifier for overlapping Prakriti detection. Here is our table of contents. First we'll talk about introduction, objectives, then methodology, results and discussions, conclusions, and finally the references. So, as we all know, Ayurveda, an ancient medical science dating back over 5,000 years in the Indian subcontinent, stands as the cornerstone of holistic healthcare. Its profound impact lies in the holistic consideration of an individual's physical, mental, and emotional health. The pivotal classification system, also called the dosha or the prakriti, identifies the unique combination of three fundamental energies shaping each person. This dosha insight is not only determines individual characteristics but also aids in grouping individuals with similar dosha profiles, paving the way for enhanced and personalized medical practices. Moving on, we'll talk about the objectives of our paper. This research seeks to revive the ancient practice of identifying Prakriti types, harmonizing nature and individual characteristics. Focusing on Vata dosha, Pitta dosha, and Kapha dosha, the study addresses the complexities arising from overlapping Prakriti clusters in individuals with multiple doshas. Utilizing the K-modes method, the data is clustered into seven overlapping categories, facilitating the development of an ensemble classifier. This classifier aims to accurately categorize instances into the appropriate Prakriti class, with performance evaluation using multinomial naive Bayes and an ensemble multinomial naive Bayes classifier.
Now I will talk about methodology. For the description of data, in our study, we leveraged a data comprising of 133 attributes from 147 individuals, encompassing diverse features such as body shape, hair characteristics, skin quality, voice clarity, and eye shape. To ensure each data impartiality, each organ underwent categorical pre-processing. A key aspect of our research involved the initial dosha classification conducted in collaboration with Ayurvedic expert Dr. Milind Bidve. This collaboration not only enriched our dataset but also ensured a comprehensive understanding of dosha classification grounded in Ayurvedic expertise. Next, I'll talk about data pre-processing. In this phase, we tackle multiple missing values efficiently by using the forward filling technique, particularly effective for categorical data. Substituting values based on previous non-missing data points, we enhance dataset completeness before seamlessly transitioning it into feature engineering for a thorough analysis. For feature selection, we use select k-best to efficiently rank features by significance, identifying and eliminating redundancies. This method evaluates statistical relationships between the target variable and employing ANOVA for numerical and chi-square for categorical data. The importance of each attribute is determined by its value in the scoring matrix, facilitating the extraction of ranked attributes based on chi-square test results. The next step is the establishment of seven clusters. This study expands Prakriti types from 3 to 7, categorizing overlapping doshas like Vata dosha and Pitta dosha. Using K-mode clustering on a dataset rich in categorical features, our refined approach identifies centroids based on attribute modes. The iterative process yields 7 clusters tracking dissimilarities and moves over 100 iterations. Next is the Ensemble MNB classifier model. The multinomial naive Bayes classifier is specifically tailored for categorizing categorical values. It utilizes Bayes' theorem to predict the Prakriti class for new input instances by calculating the likelihood of an instance within a particular class. The model is chosen for its aptitude at handling categorical values and evaluating word frequency in our dataset. Next, I'll talk about results and discussion. To prepare the model, we split the data into 80% training and 20% testing. The mixed Prakriti types in training are fitted and testing assesses metrics. We explore two multinomial naive Bayes variants considering size, attributes, and matrix. Adjusting test size mitigates imbalances during training and testing. Analysis includes 40% and 60% test sizes. Our goal is to classify individuals into 7 doshas using MNB and Ensemble MNB. The Ensemble MNB outperformed with an accuracy of 0.87 due to bias reduction. In a test size with a size zero point 0.2 and 40 features, the MNB achieved an accuracy of 0.83. With features at 60, both algorithms showed comparable results, potentially influenced by ensemble learning randomness. And finally, for our conclusion, our study crafted a Prakriti classifier for k-moods clustering, representing 7 groups. These clusters served as label data for an ensemble classifier, addressing overlapping Prakriti types. Future plans involve exploring alternative machine learning models to efficiently provide Ayurvedic-based health recommendations, contributing to the revival of ancient practices and medical advancements. These are our references. That's it for our presentation. Thank you for listening it patiently.